Okay, now we're going to continue on with the parent functions. The next one I want to look at is the square root, or the exponential function. And I've already written in much of this for you. And I did this because I want to be sure I've got everything completely right. The exponential function is generally written e to the x. It is sometimes also written 10 to the x. It's used a lot in sciences. And so our f of x would just be e to the x or 10 to the x. This is called an exponential function. When we plug in numbers, if I plug in a -2 here, and I'm going to use the 10 to the x, if I do 10 to the -2, that is equal to 1 over 10 squared. That negative just means put it into a fraction. And so 1 over 10 squared is 1/100th. So at -2, this function is very small. It's very, very close to 0. At 0, anything to the 0 power is 1. So 10 to the 0 is just 1. When I square 10, I get 100. And so when I plot this, I've got ones that are very, very close to 0. Then at 0, it goes to 1. And then it goes, when I get to 2, it's already to 100. So it goes up very, very quickly. Our domain for this is all real numbers because everything will be included. Our range, however, is y will only be bigger than 0. Okay? Because it can't actually touch 0. There is no exponent that will get it to 0. So after that, we're going to go to logs, and I go to logs here because it's really the inverse of the exponential. And I'm not going to plot this one. I will just draw you the general picture of it. It's normally written as the log of x, or ln of x, which is the natural log. This is the log or logarithmic function. And what it looks like is this. It gets really, really small down there, and then it jumps to 1, and then it gets very quickly that way. And if you look at this and compare it with the exponential function, you can see as this is getting small next to the y-axis, this one was getting small next to the x. Okay? And so it's really the inverse of the exponential function, which we'll go into later. The domain for this function is x such that x is always greater than 0. The range for this function, however, is that y can equal or be an element of all real numbers. And so if you look even at the domain and range, the domain here can be all real numbers. The range here can be all real numbers. The range for my exponential is always greater than 0. The domain for my log is always greater than 0. It's an inverse function because of that. Okay, so if I take and go to the last two parent functions that I'd like us to learn, the first is 1 over x. 1 over x, and it is called the rational function. And just remember, ratio is always a fraction. So it's a rational function. Sometimes it's also called the reciprocal function. Okay, for this function, we can plug in a lot of different things for x, but there's one we can't. So let's look at some plots. Let me do a -2, a 0, a 1/2, and a 2. Okay, if I look at 1 over -2, I just have a -1/2. So I'm good with that. If I look at 1 over 0, I have something that does not exist. I can't have anything divided by 0. It can't happen. So here we just have a DNE. At 1/2, I have 1 over 1/2. That's just like saying 1 divided by 1/2, which is the same thing as saying 1 times 2 over 1. So it just equals 2. When I put 2 in here, it becomes 1/2 again. Okay? And so when I plot this, and I probably should plot a negative 1/2, the negative 1/2 will give me a negative 2. Okay, so let me plot this at negative 2 is 1/2. Negative 1/2 is negative 2. And 0 doesn't exist. And I have 1/2 is 2. So at 1/2 I get 2. And at 2 I get 1/2. So this function is going to look like this. It can never cross the y or the x-axis because it can't equal to 0. The x can't be 0. And if the x can't be 0, the y can never get to 0. Okay, so our domain here is x such that x does not equal 0. It can equal anything else. Now, our range will be the same, but we could have written them both